And I'm back. I don't know what happened, but Screencastify cut my video. Anyway, activity 3, building the inverse function. As what I said, use the two representations of f of x to find an equation for inverse of x. Now, how will this table help you to understand what inverse function meaning? Look, how was the table useful in the first task to find inverse of x? This is how will I tell you. Now, here's the clue. To build the inverse function table, the input and output variables need to be switched. Okay? Oops. Not yet, not yet, not yet. Needs to be switched. Hold on. Let me show you. Needs to be switched. Okay? Needs to be switched. Now, you are basically switching the position of the y to the x and the x to the y. Now, to find an equation for inverse of x, we can think of the column on the right as the inputs and the column on the left as the outputs. Now, if you're going to take a look at this, so your negative 6 will go here and your negative 1 will go there. Look, this is how the table look like. It turned to an inverse. Negative 6, negative 1, negative 5 to 0, negative 4, 1, negative 3, 2, negative 2, 3. Again, this is before your y, and now it turns to x. Make sense? Alright, inverse function. Now, here is an example of an inverse function in a graph. If you're gonna plug this in, I would love you to plug that in through changing the f of x to y, both of them. Now, if you plug that in into the graph or into Desmos, you'll see this equation on the right. This one is your f of x. Now, this broken line right here, this dotted line right here, intersecting the center, the point of origin, will be your line of symmetry. So this is y equals x. That's where the mirror will happen. Now, if you plug in the equation in Desmos, how were the graph f of x and y equals x helpful to find inverse of x in the second and third question? Look at this. Now, reflecting the graph f of x across the line y equals x, that's what I said earlier, it generates the graph of the inverse. This is a new function can be found by finding the slope and the y-intercept. So how will that happen? Again, plug this in Desmos, and then if you have the equation y equals 1/2 x minus 3, then I think I have that. Oh yeah. Look at this. Wait, let me remove that. Okay. So again, you're gonna plug in this way. I change f of x to y. Y equals, look at this, y equals 1/2 times x minus 3. And then this is what I got, this graph right here. Okay, this is f of x. And now I'm gonna switch them. Y inverse of x, 1/2 will stay, and then x will become y. Now, your graph should look like this. Yes, it will reflect like that. Now, your y equals x, which serves as your line of symmetry, will tell you that this two mirrors everything what's on the left and the right. Make sense? Alright, let's do number 3. Look at this. F of x is equal to 3 times x minus 1 plus 2. Now, if you're going to plug that in Desmos, then you have y equals 3 times x minus 1 plus 2. And then, again, same thing that we did. You just need to switch x to y and y to x. Now, don't worry because Desmos accept and know how to read the x in term, the equation in terms of x. So that's why Desmos can still show you how the graph looks like. So, at the beginning of your equation, this should show up, this line right here, which is your f of x. And then again, as what I mentioned earlier, this is your line of symmetry. which would be y equals x. And then, when you plug this in and change everything and switch x to y, it will reflect as this one. You see? And now you can tell that from the line of symmetry, it mirrors everything what's on the left and what's on the right. Make more sense through graphing? So if some of you are asking or wondering, I should say, that is the line of symmetry always stays in y equals x? The answer is yes. Alright, it always passes the point of origin. And again, it comes always from y in the middle of y and x. Alright, that's where only the mirror or the line of symmetry. Any question? Alright, next. So, building the inverse function. Okay, how do f of x and inverse of x compare to each other? The addition and subtraction signs are switched, as what I told you at the second PowerPoint, I think, like those yellow ribbons. And then specifically, in the first question, 5 was subtracted from the input in the function, and then 5 was added to the input in the inverse function. You cannot probably comprehend of what I'm talking about here, because on the next slide I'll show you what this is. Also, the multiplication and the division operations are switched. For example, so in the third function there's multiplication by 3, and then the inverse will become multiplication by 1/3 or division by 3. So what are those? You still don't understand, because it's just a wording or guiding you in how you will understand inverse function. Now look at this. This is what exactly meant by the previous slide. So f of x, which is the original equation, is 1/2 times x minus 3. If you get the inverse of that, that will turn into 2 times x plus 3. What does it mean? What do you notice about the slope of the two graphs? Where are the slope, Miss Kapasha? The slope is the number before the equation, or also known as stretch and compress. Now, your compress has an inverse of a stretch. You see that? If another stretch, the inverse of that would be a compress. It's the same thing what I said. Sorry, again. If the given is a stretch, and then your inverse is a compression. Make sense? Alright. Now, look what happened here. Let's read how the equation happened. So, again, this is the original equation. From a slope of 1/2, this is a compression. Now, look what happened. The slopes are reciprocal. So, 1/2 turns to 2. Because that is what the inverse says. From minus turns to plus sign, or from minus turns to addition, and then from a 1/2 it turns to stretch, which is a 2, or a reciprocal of 2. Make sense? Alright. I hope you are getting at least a comprehension of what or how inverse functions are working. Now, I have a Desmos activity titled Lesson 1.8, Building the Inverse Function. I want you to pause this video and spend 6 minutes to those questions, but please remember that an inverse of the original function x will be inverse of x. Okay? Whatever we did in our previous slide will reflect on this activity. Alright, see you later after 6 minutes. Go. Pause the video. Okay, now we're back. So let's talk about invertible functions. I know this is a word which is very not familiar with everyone because none in your Math 1 and Math 2 discuss about invertible function. So here are the strategies that you need to remember when you are looking for an invertible function. Your graph, also graph the inverse by reflecting over the line y equals x. Remember what I did earlier? Let me change the color. If I do this, this is your y equals x. Okay, that's the line y equals x, the green one. Switch coordinates of identical points to build a graph of the inverse. Now, what is switching is the table that we did that we're switching the x to y and y to x. Use horizontal line test. Given a graph, look at this. What is a horizontal line test? Okay, if this is your graph and I uses horizontal line test, so horizontal line test will be that. Now, recognize the graph that change direction will not have an inverse that is a function. Now, you see how many times that your horizontal line touches the actual graph? So meaning, this graph is not a function. It did not pass the horizontal line test. Make sense? Alright. Probably you will understand more of this once we go along with the next example. Alright. Now, again, just to make sure that I at least give you a heads up of what an invertible function means, functions with inverse that are also functions are called invertible. Meaning, at the beginning of the equation, when you graph them and it passes the vertical line test, and then you take the inverse and you graph it and it passes the horizontal test, meaning this is invertible. We can also say that invertible functions have inverse functions. Make sense? Alright. Now, let's take a look at this example. Now, invertible function, activity 1, page, what page is this? 112. Okay? Now, take a look at this equation. This is a lot. Okay? This is a lot. If you're gonna plug that in Desmos, you should have this. Look. Let me show you. So, wait, there's a clue. It says, passes the vertical line test and the horizontal line test. It should pass the horizontal line test and vertical line test. So, remember what we are looking for. One of the function below has an inverse that is a function and the other does not. Inverse, meaning we need to take the inverse of this one first. Determine whether each function has an inverse that's a function, and be prepared to explain your reasoning. Okay? Now, take time to plug this in your Desmos. And again, the function x should serves as y. So this is a function. This is also a function. Because again, it only touches, or the vertical line test touches exactly one point to the graph. You see that? Okay, meaning this is one-to-one function. One input, one output. One output, one input. Alright? Now, let's do the inverse. Again, this is just a regular equation, f of x, or this is just a regular function. Okay, let's begin. So again, change your function into y equals x cubed plus 0.5x squared minus 2x minus 1. If you're gonna change that, you see all y's, and then negative 1. Now, the graph will look like that. Unfortunately, if you draw a vertical line test, it won't pass because it seems like there are 3 possible points which will be the value of x that will touches one y value. Okay? So this is, the other one, wait, hold on. This is not a function. Now, for the second one, you're going to plug in y. You are replacing g of x by y y equals 2 raised to x minus 3, and then y will turn to x, your x will turn to y, and this is how the graph look like. Then, if you do a vertical test or a horizontal test, it will pass. Because as you can see, it only hits the graph once when we did the vertical test. If you do a horizontal test, and it also touches once as well. If you do a horizontal test here, it will touch us once as well. But again, I told you, it didn't pass the vertical test. Make sense? So the other one will be a function. Now, here's the reasoning why the first graph or the first question or letter A problem is not a function. Does not, look, let me remove this. F of x does not have an inverse actually. If you reflect it over the line y equals x, the graph will have multiple outputs for a given value of x. So 1x, there's a lot of y value that will reflect. Alright? Now, for the second one, g of x or function x, function g does have an inverse. If you reflect it over the line y equals x, the graph will only have one output for any given value of x. As what I said, it's one-to-one function. Question? Alright. Next. So, I want you to again go back to your student Desmos, and this time the title will be Lesson 1.9, Invertible Function. Now, I come back after 10 minutes and we will check your answers if you got it right. Yes, you're going to spend 10 minutes for this equation or for this activity. Ready? Pause your video and come back here after 10 minutes. And we're back. Now to check functions with an inverse that is a function. Again, a regular equation, function with an inverse, and then it is a function. So cards B, C, D, and E. Okay? Their inverse graph is also a function. Now for the second set, function with an inverse that is not a function. So these are the cards A, F, G, and H. Go back and check your answers if you got it right. If not, take a look and double check your answers why A, F, G, H is not considered a function. Alright? Take a look. And then come back here. Pause my video if you want. Alright. I'll go next. Restricting the domain. Okay. Now, previously, and actually earlier today when we did our lesson, we uses braces like that to restrict any domain, right? Like x is greater than 4, something like that. This is where we need to find which one is the true statement or something like that. Now, so how to use restricting domain? So given an equation f of x equals x plus 3 squared plus 2, use a Desmos to graph the function and its inverse. To graph the function, replace f of x with y as what I've been mentioning from my past PowerPoint or slides. Your function f turns to y equals x plus 3 squared plus 2. Again, I changed function f to y. And then to graph the inverse, switch x and y by typing in a new Desmos line. You don't need to solve this equation for y because Desmos understands x equation. I mentioned this earlier. You don't have to worry because Desmos knows how to read equation in terms of x. So x is equal to y plus 3 squared plus 2. Again, I just switch them and this is switch. Okay? Nothing else. Now, is the inverse of f of x a function? How do you know? Well, we don't know. Now, for you to do that, Here's, I'm gonna go next. Okay, for you to do that, so this is what we had on our previous slide. Look at that. Now, to continue, you you will experiment with different domains to see if there is an interval on which f has an inverse that is a function. Now, create a slider to restrict the domain by typing into Desmos. Now, what is a slider? Now, your restriction will turn to a slider. Later, I will make a video in Desmos doing this slider so you will understand how these things work. Create a slider to restrict the range of the inverse. Again, this is a domain and this is a range. Inverse, which is the same range. Hold on. Which is the same restrictions as the domain of the original function by typing into Desmos. As I promised, I'll create a Desmos video for this. Okay? This is what you called slider. Okay? Slider to restrict domain and slider to restrict a range. Adjust the slider until you have found some restrictions that make the functions invertible. You can try different numbers as well as switching the directions of the inequality sign. Alright? Watch out for the next video. Desmos video. Oops. Desmos. Alright?